Hi doctor, my name is Lim Boon Qi and my metric number is 277532. Today I want to present for the question 1, which is about discuss and sketch the following function fx equal to x power of 5 minus 5x power of 3. For the first, I want to find the x-intercept, so I let the function equal to 0 and then I get the x-intercept answer as 0, 0, negative square root 5, 0 and square root 5, 0. Second, I will find the y-intercept. So I let the value of x equal 0 in the functions and then I get the y-intercept answer as 0, 0. For the third, I will find the open interval where the function is decreasing and increasing by carrying out first derivative. So for this case, the f prime would be 5x power of 4 minus 15x power of 2. So I will set the f prime x equal to 0 and then I will get these 3 points. It means that I have the value of 0, negative square root 3 and square root 3. So it's not changing on this point. So I want to know what is happening on this or interval between the point. I have listed out all the interval at here and then I also have listed out all the factors that I have done before at the front page. And then I also want to know what is the sign of f prime x so I can know what is happening on the function. So all these signs are getting from multiple from here, such as this one, positive, multiple negative, and multiple negative. I will get the positive. It means that for the function is increasing on the interval between negative infinity, negative square root 3. And then this one get the negative, so it means that it's decreasing on the interval between negative square root 3, 0, and then this one negative is also decreasing on the interval between 0, square root 3, and then this one get the positive, so it means that it's increasing on the interval between square root 3, infinity. So for the next, I want to find for the x-coordinate of the inflection point. By finding this, I would like to carry out for the second derivative. In this case, second derivative of the function would be 20x power of 3 minus 30x. Set the second derivative of the function equal to 0. As a result, you will get the answer of x-coordinate as negative square root 3 over 2, 0, and positive square root 3 over 2. Besides, it also need to find for the open interval where the function is concave up and down. So as before, I have carried out for the second derivative and I already know what is the value of x, which are 0, negative square root 3 over 2, and square root 3 over 2. So for now, I want to know where the function is concave up and down between all these intervals of the point. So I have listed out all the intervals and also list out all the factors. In addition, I also want to know what is the sign of the second derivative of function so that I can determine for the function where it's concave up and down. So all sign from here is getting from here by using multiple. So it means that if second derivative of the function get the negative sign like these two, it means that the function is concave down in those intervals. And oppositely, if get the positive sign, it means that it's concave out in those intervals. So for the local minima and maxima, is look back for the first derivative. We know that we have done the first derivative before and then we have get the x value which are negative square root of 3 and then 0 and then positive square root of 3. So we use these 3 points to do our local minima and maxima. For the value of negative square root of 3, they have a local maximum at 10.3923 because f prime x1 bigger than 0 and s prime x2 smaller than 0. And then for the value of 0, there's no local maximum and minimum because they have same sign at both sides. And then for the value of square root 3, they have a local minimum as negative 10.3923 because f prime f1 smaller than 0 and then s prime s2 bigger than 0. For the last part is sketch the graph of function. For now, we are going to find the corresponding of x value for the important point. This one is the important point because it is the x value that we have found when we are carrying out for the first derivative and second derivative. This is the graph that I have sketched, and then this 5 point is the important point that must plotted on this graph. This is the maximum point and this 3 is the point of inflection, and then this is minimum point. So from this graph you can see that from here to here is concave down, and then from here to here is concave up, and from here to here is concave down, and from here to here is concave up. This is all from me. Thank you.